All right, number 1 here for the solutions. They give you an equation. You can tell that this is going to be a calculator one. So it's important to know what it is. And the question is, it's defined as the rate. So what you're looking for already is a derivative. So 82 plus 4 sine t over 2 from 0 to 30. That's already the rate. Okay. And what is it the rate of? So it's traffic flow passing through an intersection. Cars per minute. So F of t is measured in cars per minute. T is measured in minutes. A, to the nearest whole number, how many cars pass through the intersection over 30 minutes? How many? That's an integral question. From where to where? 0 to 30. I'm integrating the rate. Type that in. Type it all in. Press pause. See if you get the same answer as me. And to a whole number that's 2,474 cars. Did you try it or did you just copy? You need to practice your calculator. B, is the traffic flow increasing or decreasing? That's a derivative. So I need to take the derivative of this at what number? At 7. So take the derivative of this at 7, use your calculator, and you get the answer negative 1.872. Because it's negative, the answer is it is decreasing the rate, right? Because the rate is negative. C, what's the average value? What's that? That's an integration question. Over how many minutes? 0, the average value from 10 to 15 of that function, and then divide by the difference of the bounds. Press pause, use your calculator. Can you type this in and get the same answer as me? So it's 81.899 cars per minute on average. Part D, what is the average rate of change? That's AROC. It's going to be a fraction over 10 to 15. So this is y2 minus y1. x2 minus x1 is 15 and 10. I need to plug in 15, subtract, plug in 10. So plug 15 into here, subtract, plug in 10, divide by 5, press pause. Use your calculator, challenge yourself. See if you get the same answer as me. So I got 1.517, and that's because you're doing the derivative of a derivative. It's cars per minute, or minute squared. Number 2. You're given a graph, and you're asked to find the area enclosed by these graphs. So we're going to go top, subtract, bottom, right, for that. And it goes from 0 to 1. So the setup's pretty simple. You already know, you know you're integrating. You know it's from where to where. And once it's defined, you can just write it as f at x subtract g at x. But just actually type in what f at x and g at x are. Use your calculator. Make sure you put parentheses around whatever you put g at x so it stays in front of the subtract sign and the calculator will do it correctly. And you get the answer 1.133. You should check to make sure that's good. Part B is, look at my head here. Find the volume is revolved around the line y equals 2. So that's up here somewhere. I'm going to revolve it. So it's a circle. Is there a space? Obviously. So we're going to go from 0 to 1. It's pi. We have 2 of them for the big radius and the small radius. So the big radius is going to go from this line, which is 2, subtract the bottom, which is g at x. So it's 2 subtract g at x. The small radius, 2 subtract the top curve. So 2 subtract f at x. Type this in. Again, actually use what g at x and f at x are. Make sure you use parentheses around this. Parentheses around this. Type it in. I really want to know if you typed it in correctly. And the answer is 16.179. Challenge yourself. Did you get that answer? Do you know how to use your calculator? All right, part C. Part C asks, let h be this function from 0 to 1. For each k is always positive, enclosed by the graphs h and g, is the base of the solid with square cross-sections perpendicular to the x-axis. There is a value of k for which the volume of this solid is equal to 15. Right? But don't solve an equation involving an integral expression that could be used to find the value of k. So because it's positive with g at x, we know the k is above. So when you go top, subtract bottom. So first of all, it's going to go 0 to 1. That new function is above. It's the top. So I'm just going to write down h at x equal, subtract the bottom part, which is g at x. And we know that area is given, and the answer for the area was 15. So I want you to go solve, type this in, comma k, diamond enter, see if you get the answer. So the answer should be, or do they say don't look for an answer? Just do an, oh, that's done. They said don't even solve for k, so that's a good answer. Number 3. You should try it first. You should read it first. You should think through it first. A particle moves along the y-axis so that the velocity is given by that equation. At any time, at time t equals 0, the particle is at y equals -1. And they note that means arc 10. Notice that it's along the y-axis, so it's going up or down, not going left or right. Find the acceleration at 2. So if you have the velocity, how do you find it? Is you take the derivative of the velocity and plug in 2. So I want you to see if you can take the derivative at 2 and get the same answer as me. You're going to have to figure it out, right? That you can type it in and get the answer. Keep trying until you get it. So if you did it correctly, you get -0.132. The next question is the speed increasing or decreasing? At what number? At 2. So in order to understand that, I need to know what the velocity is at 2 and then compare these numbers. So the acceleration is that number. What's the velocity at the same number? So use your calculator and plug it in. And notice the signs are the same. That means the speed is increasing. If the signs were different, then the speed would be decreasing. So if they both are positive or both negative, it's increasing. And this is the reason why. Next question. Find the time when t is greater than 0 at which the particle reaches its highest point, so your maximum, and then justify your answer. So to understand that, the position is x at t. The derivative of that is the velocity, and you take the derivative of this equal to 0. So we're going to take the equation you're given, make it equal to 0, and solve it, and find at what time. Let me show you. When it's trigonometry, it's usually better to graph to solve that. So if I graphed it, and if I have something here, go menu, actions, and then clear it, and then press tab. So for this one, what do we have? So 1 minus inverse e to the t, well, it's going to be x for this one. And it's from 0 to 2. But I can see it crosses right here at the beginning. See where it crosses? Change that window so you can see it. It's just 0 to 2. So you can see where does it cross. And so if I go menu, analyze 0, where does it cross right there? So to the left of it and then to the right of it, it's going to highlight over it. So I got 0.443. and it goes from above to below. So that's a maximum. So the question is, find the time at which it reaches its highest point. So it's at t equals 0.443. There's not even units given. Next, it says find the position of the particle at t equals 2. Is the particle moving towards the origin or away from the origin at t equals 2? All right, the position, we're going to integrate the velocity. Now, do we have a starting value? So it says at t equals 0, the position is at -1. So we start at -1. We're trying to find this. So the starting value is -1. So we're going to integrate from -1 to the number I'm looking for, which is 2. Oh, sorry. Try again. From 0 to 2. So at 0, the position's -1. Then integrate the velocity from 0 to what you're looking for, which is 2. And then use your calculator. And you get -0.360. If I think of that on a number line, like there it is, -1.36. Is it going towards the origin or away? What direction is it going? In fact, I should actually write it vertically. Here's 0. So is it going to go up or down? So what's the velocity at 2? It's negative, right? So the direction it's going, it's negative already and it's going down. So is that going away or towards? And the answer is it's moving away. And so how do you know? Because you know the location and you know the velocity. So with the location and the negative velocity, it's moving away from 0. All right, turn the page. Number 4. Consider the curve. This one's no calculators. So step 1 here is to take the derivative implicitly and see that it matches. So this is 2x. This is 8y, but it needs a hook, y prime. That's 0. This is the product rule. The first times the derivative of the second plus the second times the derivative of the first. Now we need the y primes together. So we're going to subtract 3x. And this is 3y. We're going to subtract 2x. And then we're going to factor out a y prime. So it's 8y, take away 3x, and then divide. And you have shown that they are equal to each other. The order doesn't matter, though the order does match. So can you show the steps implicitly to show that the derivative is that? And then part B, show that there's a point P with x coordinate 3 at which the line tangent to the curve is horizontal. So if it's horizontal, that means the derivative is equal to 0. So take the numerator equal to 0, and we're going to solve it. So if the x coordinate is 3, that means the y coordinate must be if I solve this, add 6 and divide by 3, the y coordinate must be 2. So at x equals 3 and y equals 2, this is when the derivative is equal to 0. Next question. Find the second derivative at that point. So we have a point 3, 2. Find the second derivative. So to find the second derivative, I'm going to go the bottom times the derivative of the top minus the top times the derivative of the bottom and then the bottom squared. And then I plug in. So I need to plug in 3, 2. So I'm going to plug in 3 and 2. Now for the derivative, I'm going to plug in 3 and 2 here. Oh, and if I plug in 3, 2, oops, it should be the other way, 2 this way and this way. The answer is 0, right? The whole point was the derivative is equal to 0. So that's 0. And then we just keep plugging in. Oh, I'm plugging in wrong. So x is 3 and y is 2. So y is 2. X is 3. The derivative is 0. Plug in, what is it again? X is 2. Sorry, y is 2, x is 3. And then reduce it down. So you actually get a negative answer if you do that, if you solve this. So what does that mean? What does a negative concavity mean? So if you have a negative concavity, that means at that point it's a maximum. Number 5. The graph is here above. Are you starting to feel better with graphs? And it's defined this way. We see this a lot, right? Find the g at 0 and the derivative at 0. So g at 0 means to plug in 0. So I'm going from negative 3 to 0. The first thing I look at is the bottom number smaller. It is. I know it's area. So from negative 3 to 0, can you find that shape? That's a trapezoid. So half the base times the height or the width. So the width there is 1, 2, 3, and the 2 heights. So you have the width, and then the first height is 2, and the other one's 1, so 2 plus 1. And that's a good answer, or 4.5. G prime at 0. So what's G prime at x? So if I take the derivative here, it's just f at x. So g prime at 0 is just f at 0. So what's the function value at 0? So at 0, the function value is 1. And you just answer the first 2 parts. Part B, find all the values of x where g retains a relative maximum. So first, I need to know where the derivative is equal to 0. That's when f at x is equal to 0. So if I look off the graph, what are the x-intercepts? So at negative 4, at 1, and at 3. So the x-intercepts are at negative 4, at 1, and at 3. And then I'm looking above and below to see if it's positive or negative. So the first part of the graph is below, it's negative, and then above, it stays above, and then it goes down again. And the question is, where is there a maximum? So not here. So there's a maximum when x equals 3 is the max, because it increases to decreases. All right, next question. Find the absolute minimum from negative 5 to 4. So this decreases, if you look at the area, it decreases a little, and then it increases a lot, and then it decreases a little. So right here at 3 is going to be a maximum, a relative maximum, or an absolute, or absolute minimum, absolute minimum value. So we go down a little, and then up a lot, and then down. Right here at the beginning, when it goes to -4, right here is going to be the low point. It's like it goes down a little, it goes up a ton, and then down a little. And like, oh, okay, so it goes down, it goes way up, and then down a little. Where is that? And that's when x equals -4. And then it says, what is it, right? So it's at x equals -4. So then what is g at -4? So then you have to plug in to the equation. Notice the bottom number is bigger than the top. So first of all, what is the shape from -3 to 4? It's a triangle. It is above, but we're going to flip it around because the bounds are different. So it is going to be negative even though it's a bound. It's half the base times the height. And there's your answer. So that answer is -1. D. Find all values of x at which the graph has a point of inflection. So we know that the first derivative is f at x. The second derivative then would be the first derivative of f at x. So if I want to know where it's concave or where a point of inflection is, when I'm looking here, I'm looking at the derivative of f to find that answer. So if this is true, then I'm looking to see the turning points. Every time the graph turns, it creates a point of inflection for g. So there's one at x equals at 2. We have a turning point. We also have a turning point at 1. And we have another turning point again at, try it again. So we have a turning point at -3, another turning point at 1, and another turning point at 2. Those are the values. Let's see if I can write those down. -3, 1, and 2. Those are all point of inflections because those are all the turning points for the graph. All right, number 6, last one. Let's do this right here in the book. Take a picture of this book that you did the slope field. So for every point here, I notice that when x is 0, everything's 0. So these are 0 right here. Whoops. Try it again. This is 0 right here going down at 0. Ignore that one. When y is 1, it's also 0. So here is 1. Ignore that. So at -1, 0, we have -1 squared times -1. So this is -1. So this should look like this. +1, 0. Same direction. -1 and 2. Oops. -1 and 2. It's going this way. +1 and 2. -1, which will become positive, and 3. So even steeper, and this will match over here on this side. So where are they all positive? So when y is greater than 1, the slopes are positive. So x is always positive. When y is bigger than 1, that means everything is positive. For part C, find the solution to this. I think we have room here. What do you think? We're going to separate the variables. So we're going to divide by y minus 1 and multiply by dx. We're going to integrate this. This is a logarithm. We're going to add 1 to the exponent and divide. We can plug in a point. So we have a point to plug in, 0, 3. So if I plug in 3 for y, I get ln 2. If I plug in 0 for x, I get c is equal to ln 2. Then I'm going to solve this. So exponentially, So it's x cubed over 3 plus ln 2. So it's e to that exponent, and then just add 1, and you have your answer. You don't have to make it look prettier than that. And this equation then matches that slope field. Is that it? We did it. All right, Mr. G Math over now. Great job reviewing with me today. Till next time.